Hi, well, we're continuing on with our kinetics unit, and in this video, we're going to talk about reaction rates and stoichiometry. And so we've already looked at different factors that affect the rates of a reaction. We've looked at instantaneous rates, and now we're going to look at the stoichiometry from a balanced equation. And so we'll go back to the very same equation we've been looking at so far. We've got nitrogen dioxide decomposing into nitrogen monoxide and oxygen. So if we were to look at this, the rate of disappearance of the nitrogen dioxide would equal the rate of appearance of nitrogen monoxide. But the rate of appearance of oxygen would only be half the rate of disappearance of nitrogen dioxide, or half the rate of appearance of nitrogen monoxide. And to understand why, we can also go back and see this graphically. Maybe you noticed this on the graph, but look at this on the graph. Here we've got, look at the slope of the disappearance. The slope of this line would be concentration over time, the change in concentration over time, which is rate. And so this slope of this line, the disappearance, looks like it's the same as the slope of appearance of the nitrogen monoxide line. But the slope of the oxygen line, it's not nearly as steep. And if you did some of these calculations, you would find that it's half that of the nitrogen monoxide. So the rate of appearance of oxygen is only half the rate of disappearance of nitrogen dioxide or nitrogen monoxide. And if you look at the balanced equation, you'll see the answer. See these coefficients here of 2 and 2. The same coefficient means that their rates are the same. The rate of disappearance of this equals the rate of appearance of this, but this coefficient is only half of those coefficients, being a 1 here, and so its rate is half that, the rate of appearance of the nitrogen monoxide. And so again, the stoichiometry, these coefficients in the balanced equation, hold a lot of clues to what's happening in our balanced equation. So if you know the rate of one thing in the balanced equation, and so they would have to tell you one of the rates, then using those coefficients in your balanced equation and doing that mole-to-mole ratio that we've been doing all year, you'll know the rate of everything else. So use those coefficients properly. So we can do a practice problem here. We have a decomposition of something different this time. It's dinitrogen pentoxide, and here's the equation, and it's balanced. And they give us the rate of the decomposition of the nitrogen pentaoxide. And they say that rate of decomposition, or its rate of disappearance, is 4.2 times 10 to the negative 7th molars per second. And they would like to know what is the rate of appearance of the NO2 and what is the rate of appearance of oxygen. All right, now let me just stop for a minute. I'm hoping that you're following along in your textbook. Also, you'll see other teachers give an equation, and it is in your textbook, where they set all these rates equal to one another. And so there is an equation for doing this type of a problem, using an equation with the coefficients, but I'm not going to use it here because I'm going to use the stoichiometry the way that we've learned in the past. And so here we go. Let's go ahead and do this problem. All right, so we need to look at our balanced equation, and we know that the rate of our disappearance is 4.2 times 10 to the negative 7th moles of the dinitrogen pentoxide per liter per second. And they would like to know the rate of appearance of nitrogen dioxide. And so there are 4 moles of NO2 to every 2 moles of N2O5. And the moles of N2O5 will cancel, and we'll be left with moles of NO2 per liter, so molars of NO2 per second. And again, notice you put the moles of what you want on the top, the moles of what you have on the bottom to get rid of them using your coefficients in the balanced equation. And we are going to find that it's 2 times that, which is 8.4 times 10 to the negative 7th molars per second. And that is for the rate of appearance of NO2. Okay, so the rate of appearance of NO2 is 8.4 times 10 to the negative 7th molars per second. Let's look at the rate of appearance of oxygen. So again, start with what's given. You know the rate of one thing in this balanced equation, and that is the rate of disappearance of the N2O5. Do your mole to mole ratio. We've got 1 mole of oxygen for every 2 moles of N2O5. And so when we do this, the moles of N2O5 cross off. We've got moles of oxygen per liter per second, so molars of oxygen per second, and we're going to have to divide that in half. So it's going to be 2.1 times 10 to the negative 7th molars per second for oxygen. So this is the rate of appearance of oxygen, and this is the rate of appearance of nitrogen dioxide. So once again, we know the rate of disappearance of this. Using our coefficients in the mole to mole ratio, we can get the rate of appearance of our products. All right, so I hope that's helpful, and we're going to practice this.